welcome to 17th lecture. Okay, and we were discussing about the electrical degree and mechanical degree and what is the difference. The whole idea is this, that if it is a two pole machine, your B distribution, if it is sinusoidal, the fundamental component of that B distribution only we will consider. We will see that how this can be made more perfect a sinusoidal B distribution, but assuming that B distribution is this, a conductor if it is moving underneath this B distribution, then the induced voltage across it will be just same as this B distribution, and this is the space angle. Mind you, this theta is space angle, and this is your omega t. What is omega? Omega is the speed of this rotor in radian per second, where from we started. Speed of the rotor is n rps, which I can measure with a tachometer. So, that is the mechanical speed, anyway whatever it is, but to calculate the induced voltage I required the V, not omega, and V I must therefore expressed in terms of diameter of the rotor. If it is d, V is equal to pi d n, but mind you n is in rps. It may be expressed in rpm, but okay, rps, and the angular speed is in radian per second, which is 2 pi n radian per second. Then I told that if the conductor, suppose the starting point is here and it is moving in this direction. So, in this axis omega t is the position of the rotor. Suppose here it was omega t equal to 0. So, okay, at any time t it comes, this is at any time t, this is the position of the conductor at any time t. So, this is omega t, this time. At that time what will be the voltage? BLV, at this time BLV, and when it cross pi by 2, it has reached maximum voltage. Once again 0 voltage, conductor comes here because there is no B, and then it reverses its polarity, and a complete cycle of EMF will be obtained when the conductor returns back here, and there is no distinction really between electrical and mechanical angle when the number of poles of the machine is 2. Now, let us see what happens if it is a 4 pole machine. Suppose I will first draw the rotor, otherwise I am sketching the rotor so badly. So, this is the thing. Suppose this is south pole. We know how to create a 4 pole structure by not using projected poles only, by passing some current through the coils housed in stator. Okay, those I am not repeating. So, suppose effectively it comes to this, some south, north, south, north. Please go through the earlier lectures where I have indicated how if a rotor or stator irons can be magnetized such that 4 poles will be created using 2 coils, you recall that. But anyway, just for understanding this I will do like that. Therefore, 1/4 of this will be under the influence of north pole, next quarter will be under the influence of the south pole, and next quarter will be under the influence of north pole, and this is once again under the influence of north pole. And these lines are the neutral position where from north to south transition is taking place. Here the flux density will be 0, fundamental component of flux density. Now, you see, if the conductor, first let us not draw anything, but let us argue like this. You have a conductor which is moving with a speed n rps, and that n rps is mechanical thing. We know only mechanical speed we are used to. I can use the tachometer. Tachometer records the mechanical speed in real terms, so much rotations, so many rotations per second and so on, and suppose the conductor is moving with n rps. N is in mechanical speed. Of course, one may question, we have not yet come to know what is electrical about it. So, what is the point of telling mechanical or electrical? Let us try to understand now. That is why I will not do first any maths. Let us see, this conductor is moving with some RPS, mechanical RPS. Now, when this conductor in this position and it is moving in the clockwise direction, voltage is 0, then it will have peak value when it comes under the center of the south pole, because I have assumed the distribution to be sinusoidal in nature. Suppose I am measuring theta is equal to 0 here. So, your B distribution will be this one. Now, it will become maximum here, then when the conductor comes here, voltage will be 0, indicating this point. It will be maximum when it comes here, but in the opposite sense, because it is now under north pole, same conductor, once again 0 here. Then once again it will have maximum here, 0 here, maximum here. So, this is the thing. So, this is B distribution. Now, you see, when the conductor moves a pair of poles, that is it starts from here, reaches maximum, reaches 0 in one polarity of the voltage, then it reaches maximum and reaches 0 in the negative cycle. That is, the conductor has crossed only a mechanical angle of 180 degree and a complete cycle of EMF is available. That is the thing. In earlier case, when the conductor has moved by 360 degree mechanical, your EMF has also produced one cycle of EMF. But here you can see, when the conductor moves 360 degree mechanical, when the conductor has moved 360 degree mechanical, 2 cycles of EMF will be consumed. That is what I want to tell. If I sketch this as theta mechanical B distribution, then what should I write? Theta equal to 0 here. Here how much should I write? B was 0 here, you have moved only 45 degree, this is pi by 4 under this heading, is not? This is pi by 2, you have only moved by 90 degree mechanical degree and got pi by 2, not pi. If this axis you indicate by theta mechanical angle, the angle the way we understand geometry. If you go on measuring like this, what I am telling, when this will be 2 pi here, you have got, so pi by 4, so pi by 2 plus another pi by 4, and this will be like that. I can indicate. The question is, but your conductor does not know all these things. It only knows whatever B is there above it, that will be the voltage. So, conductor will also generate voltage like this. So, this is voltage BLV. Voltage, do not write VLV now. So, this is the voltage of a single conductor, and this angle is theta electrical. Therefore, we can easily see the theta electrical will be p by 2 theta mechanical. So, time has come to distinguish between these two angles when it is a multipolar machine. If p equal to 2, theta electrical is equal to theta mechanical, and theta electrical, as I told you, I will indicate simply by theta. Okay. So, theta electrical is p by 2 theta mechanical. That is, over 360-degree mechanical angle, you have now brought in another two poles squeezed, same mechanical angle 360-degree in terms of mechanical angle. Suppose this is 360-degree mechanical. What essentially I have done is, I have divided this 360-degree mechanical in 4 zones. 1, 2, 3 equal zones, I am so sorry. So, one becomes north pole, south, north, south, like that. So, I have brought in another 2 poles, south, north. In 2 pole, it was not like that, only 360-degree mechanical, 180 was consumed by south pole, another 180-degree was used by north pole. But here 360-degree, 90-degree mechanical angle was under the influence of south pole, next 90-degree under the influence of north pole, then another south pole, another north pole. That is, over the same 360-degree mechanical, I have now squeezed a pair of poles, north south, south north, south north. And therefore, any conductor moving, he does not mind whatever you have done, but conductor moving, he will only see, oh, I was now under south pole sinusoidal. So, my voltage I will make this one, then in this up it will be like this, then in this up it will be like this, and in this up it will be like this. So, as the conductor moves by 360-degree mechanical, the electrical angle moved, electrical voltage that you will get, it has made 2 cycles, that is 720-degree. So, this angle is 2 into 360-degree electrical. Understood? So, this is very important. Electrical angle is equal to p by 2 theta mechanical, and one should not forget, if it is a 6 pole machine, it will be 3 times the mechanical. 3 cycles of EMF will be generated when the conductor moves mechanical angle of 360-degree round. So, this is a very important thing. Therefore, it looks like that it is necessary to distinguish between electrical and mechanical angle, space angle. So, what we will do is this, suppose I will say that this is a 4 pole machine, 1, 2, 3, 4. This is 360-degree mechanical, no doubt, but in electrical angle, if theta is in electrical, that is how I should describe this sine wave, so that it will fit in. I will write it as B max sin theta, and this theta, as I told, without any suffix means electrical angle. So, B max sin theta, and there I will indicate like this 0, pi, 2 pi, 3 pi, this is pi by 2, and so on. This is 3 pi by 2. Is that clear? So, whenever you show the bit distribution, because you do not know whether it is a 4 pole machine or 2 pole machine. So, it is better this will be giving you a true picture, and you will say bit distribution in terms of electrical degree I know. So, if it is a 4 pole machine, you know this is 720 degree. If it is a 6 pole machine, it will be 3 into 360 degree mechanical. So, I can always switch over if I like, that is okay. Coil you are telling in this therefore, if theta is you have understood the point, I hope, and it is essential to understand. Now, if you differentiate this with respect to time, you will get angular velocity d theta dt to be equal to p by 2 d theta mechanical by dt, or I will say that electrical speed in electrical radian per second will be equal to p by 2 speed in mechanical radian per second, or in other words what I am telling, this omega theta is in electrical without any suffix will be equal to p by 2 omega mechanical. This is just comes from this. So, electrical speed is always greater than mechanical speed of the machine. Okay. Therefore, while placing a coil in these slots like this, as I told you, you place one conductor. So, this is 360 degree mechanical, 360 degree mechanical. Here is the slot, here is number of slots are there. Now, if it is at this point you try to understand, if it is a 2 pole machine, then half of the slots will be under north pole and the remaining half will be under south pole. So, if you have placed one conductor in this slot, its return conductor, if it is under the center of the north pole, its return conductor should be placed under the center of the south pole. So, that the maximum voltage will be induced. But if it is a 4 pole machine, if you place one conductor in this slot which is under north pole, where the return conductor should be placed? Return conductor must be placed at 90 degree mechanical degree apart. Why? Because that will then indicate electrical angle 180 degree and you are ensured it will be under south pole, next opposite pole. Therefore, this is the thing that if you place a conductor, let it be a 4 pole machine. So, if it is a 4 pole machine, this is 360 degree mechanical, but electrically 360 degree mechanical, which means 720 degree electrical, one and the same thing. Now, if you place a conductor here, if you want to place coil, you want to make a coil, place, if you must ensure that if this coil is placed comes under the plus B max, its return must be under minus B max. That is how this separation should be. Now, what should be this separation angle for maximum voltage? In terms of electrical degree, it should be 180 degree electrical. but in terms of mechanical degree this angle is only how much? 45 degree, for not 45, 90 degree, half of this. So, this is 90 degree mechanical. Got the point? Therefore, over in a rotating machine like this, 360 degree mechanical is fixed. Now, depending upon whether it is a 2 pole machine or 4 pole machine or 6 pole machine, you know, over this 360 degree all the poles are to be accommodated. If it is a 2 pole machine, 180 degree mechanical will be under north pole, 180 degree mechanical will be under south pole. If it is a 4 pole machine, only first 90 degree will be under north pole, next 90 degree under south pole, next 90 under north pole, next will be another 90 degree. Now, in such an environment, if a conductor is allowed to move with certain speed v meter per second, then as it completes one rotation, he will cross successively south pole, north pole, south pole, north pole before it comes back to its original position. Therefore, 2 cycles of EMF will be produced, which is equal to 720 degree when we sketch a voltage waveform. Therefore, a conductor moves by 360 degree mechanical essentially means that you have moved the conductor electrically by 720 degree and 2 cycles of EMF will be produced. If it is a 6 pole machine, then 1/6, that is 360 degree by 6 is 60 degree, 60 degree mechanical, first 60 degree mechanical say under south pole, next 60 will be under north pole, next 60 will be under south pole, north pole, south pole. So, there will be 3 pair of poles, p by 2 will be 3. Therefore, 3 cycles of EMF will be produced as the conductor makes a one complete mechanical revolution. What is mechanical degree? The mechanical degree we understand in geometry, that is the mechanical degree you can measure with a protector, things like that. But when it comes to the generation of AC EMF, we immediately understand that the cycle of number of cycles of EMF which will be produced as the conductor moves around the periphery of the rotor surface, several cycles of EMF may be produced. One cycle of EMF generally 360 degree, so 360 degree electrical. Therefore, if it is a 2 pole machine, no question of distinguishing between electrical and mechanical degree, but if it is multipolar machine, I must remember that so as to correct so that I can write down correctly the expression. So, when I write B is equal to B max sin theta, this theta is in electrical. So, I will sketch it in electrical like this, and conductor will move with a velocity v. Now, what I am going to do is I am going to find out most important step, that after understanding the distinction between these two, I will try to calculate the expression mathematically. Now, I am doing a little bit of mathematics to find out the expression of the RMS voltage induced across a coil. That is what I will try to do. So, the problem definition is, let it be a p polar machine, let the number of poles of the machine be p, okay, and let let me write more formally. D is equal to diameter of the rotor, diameter of the rotor. Okay. And let small n be the mechanical speed of the conductor in meter per second. So, this is mechanical speed, how much meters it goes. Oh no, mechanical speed of the conductor, I am sorry, in RPS. How many rotations it makes, which I can measure mechanical speed. So, n mechanical, and I will indicate theta to be the electrical angle, and theta mechanical, if necessary, this may not be necessary, is p by 2 into theta angle. Okay. And the problem is like this. B distribution is given, and I will write it as B max sin theta. If I have chosen to measure theta from 0 crossing and going towards positive, this is entirely my business. So, I have considered this to be theta equal to 0, and this theta, as I told you, it is theta electrical without any suffix. So, this is pi, this is 2 pi, and this is theta, and y axis is B is equal to, in electrical angle, this is the thing. And now, I will tell that a conductor, single conductor, is moving with a speed v mechanical is equal to so much meter per second. Okay. But in a single conductor, I know what to do, but I want to use a coil. So, coil, I told, if this is one coil side, I must make sure the other coil side will be 180 degree electrical apart. Then, so the coil span is 180 degree electrical apart. It has to be always. So, that is very convenient to say, no matter whether 6 pole, 4 pole, 8 poles, coil span different in their positions in space must be always 180 degree electrical. Why? Because then only the induced voltage. So, if this coil side is under the center of north pole at any time, this fellow must be under the center of south pole. So, that you will get maximum voltage between these 2 points as 2 B L V voltage across the coil. Okay, we will continue with this 5 minutes. So, we will continue with this in the next class.